each of the following straight line functions, we are required to state the gradient. Now, we can only state the gradient of a straight line if it's in standard form. So we always need to ensure that the straight line is in the form y equals mx plus c. From that, we can just look at the coefficient of x, and that gives us the gradient of the line. Each of these, a, b, c, d, and e, are all in standard form. So all we need to do is just read off the coefficient of x in each case. So the gradient in the first line is 3. The gradient in the second line is 2. The gradient in the third. Now, the coefficient of x over 2, okay, x over 2 is a half times x. A half is the coefficient. Okay, so the gradient is a half. In D, the gradient is 3, and in E, the gradient is a third. X over 3 equals a third times x. A third is the coefficient of x. Give the equation of each of these lines, all of which have positive gradients. Okay, we know that they have positive gradients because each of these lines are sloping to the right. They actually don't have to say that. That should be inferred. You should be able to deduce that just by looking at the sketch graph, right? Regardless of the equation of each line. If a line slopes to the right from bottom left to top right, it has a positive gradient. So we know that just by looking at the graphs. We don't have to be told that. Okay, so the equation of each of these lines. Now, to find the equation of each of these lines, we need the equation of a straight line is y equals mx plus c. You need to find the gradient. And to find c, that's the y-intercept of the line. If we can read the y-intercept off the graph, which it seems like we can, then this will come from the graph itself. So let's start with the gradient. To find the gradient, we need 2 points that lie on the line. To find the gradient, we use m equals y2 minus y1 over x2 minus x1. x1, y1, and x2, y2 represent any 2 points that lie on that line. So the first thing we need to do is find 2 points that lie on the line. Let's look at the y-intercept because that is 1 point already, okay, which is going to be that point we'll call A, which is 0 minus 2. Remember that every point is written as an x-coordinate first and then a y-coordinate. So the y-intercept, y is minus 2, but on the y-axis, all x-coordinates are 0. So A is 0 minus 2. Let's find another point. Let's look at that point over there. You can pick any point you choose. Call that point B. This will be 3, the x value first, and then the y value 4. So the 2 points we're going to use in the first graph are 0 minus 2 and 3, 4. Now we can determine the gradient of AB. So y2 minus y1 is 4 minus 2 over 3 minus 0. 4 plus 2 is 6. 6 over 3. The gradient of AB is 2. So we have the gradient of AB, the gradient of the line, and we have the y-intercept, C, which is that value over there. For the equation of that line in A, the equation of AB, if you like, because we did label the 2 points A and B, so the equation of line segment AB is y equals 2x minus 2. Okay, B. Again, let's find 2 points that lie on the line. Let's look at the y-intercept. The y-intercept is here. We'll call that point A, and the coordinates are x first, which is 0, and y is 1. And then B, let's be a little bit different. Let's pick a point down here. So B will be x first, which is minus 4, and then y, which is minus 3. So A is the point 0, 1. B is the point minus 4, minus 3. So the gradient of AB will be y2 minus y1 over x2 minus x1. So there'll be minus 3 minus 1 over minus 4 minus 0. So we'll have the gradient of AB is minus 4 over minus 4, which is 1. So C equals 1. So the equation of AB, y equals mx plus c, y equals 1x, and c is 1. Now the coefficient of x, we don't put a 1 there, so we don't write a 1, it's common practice, it doesn't look very nice. So y equals x plus 1 is how we write the equation of the line. Do E. So let's find 2 points that lie on the line. Okay, this line goes to the origin, it goes to the point 0, 0. Okay, so we can call that point O. Just again, it's a convention. Point O is the point 0, 0. Let's find another point. Let's take that point over there, which is 2, 2, and we'll call that point A. So the gradient of OA is y2 minus y1 over x2 minus x1. So it'll be 2 minus 0 over 2 minus 0, which is 1. So the gradient is 1. The y-intercept, when x equals 0, y equals 0. So c equals 0, y equals mx plus c, y equals, the gradient is 1, 1x plus 0, and we don't write it like that. We just say y equals x. Exercise 3, I've left for you to complete. It's done pretty much the same way that exercise 2 is done. Exercise 4, these lines have got negative gradients. Again, they don't have to tell you that. You can just look at the graph and know that the gradients are negative because each of these lines are sloping to the left. So when the line slopes from bottom right to top left, the gradient is negative. M is less than 0. Okay, we don't have to be told they're negative gradients. We can see that they're negative gradients. Okay, again, so y equals mx plus c, still a straight line graph. Only difference here is that we have a negative gradient. So the process is exactly the same. We find 2 points that lie on the graph. If the y-intercept is visible and clear and evident, then use it. So the y-intercept here is at 1. So the point A is the point 0, 1. So we've got our first point. And let's find another point. Let's look at this point here. B, that will have an x coordinate of 2 and a y coordinate of minus 3. So the gradient of AB equals y2 minus y1 over x2 minus x1 minus 3 minus 1 over 2 minus 0. That's minus 4 over 2. So the gradient of AB is minus 2. The y-intercept is, we know that that's at point A. So C is the y value there, which is 1. So y equals mx plus c, y equals minus 2x plus 1. And this is the equation of AB. Okay. B, again, we can look for 2 points that lie on the line. The line passes through the origin. So the first point will be O, 0, 0. And then just pick any other point. Let's pick that point over there. Minus 4, 2. We'll call that point A. So point A is minus 4, 2. Gradient of OA is y2 minus y1 over x2 minus x1. So it's going to be 2 minus 0 over minus 4 minus 0. So the gradient of A is 2 over minus 4. The gradient is minus a half. The y-intercept is 0. Right, so c equals 0, y equals mx plus c, y equals minus a half x plus 0, which we write as y equals minus a half x, and this is the equation of OA. Okay, we'll do one more, then the remainder of the exercise will be for you to do. Let's see if we can find the y-intercept. There it is. At 1, let's call that point A, 0, 1. Let's find another point. Let's look at that point over there. That's going to be 4 minus 3. So B is the point 4 minus 3. Okay, so the gradient of AB is y2 minus y1 over x2 minus x1 equals minus 3 minus 1 over 4 minus 0. Gradient of AB equals minus 4 over 4. So the gradient of AB is minus 1. The y-intercept is 1, is the point 0, 1. So the value of C is going to be 1. Okay, y equals mx plus c, y equals minus 1x, we're just going to write minus x plus 1. Again, we don't write, when the coefficient is 1, we don't write the 1 in. So the equation of line C, of line AB in part C, is y equals minus x plus 1. Question 5. The line y equals 4x plus c passes through the point 1, 7. Find the value of c and then determine where the line crosses the y-axis. Okay, we can only answer part B if we know the equation of the line, and we don't know the equation of the line yet because we don't know what c is yet. Okay, once we know the equation of the line, we can then answer any question that follows. So the point, let's just call it point A. It doesn't matter what we call the point. 1, 7 lies on the line. Y equals 4x plus c. So to determine the value of c, we substitute x equals 1 and y equals 7 into this equation. So 7 equals 4 times 1 plus c. 7 equals 4 plus c. Take 4 across, 7 minus 4, c equals 3. So the line is y equals 4x plus 3. Now to answer B, where does the line cross the y-axis? This is asking you for the y-intercept. So for y-intercept, we put x equal to 0. So y equals 4 times 0 plus 3, y equals 3. So the line crosses the x-axis at the point, and let's call it point B because we've already called this point A. Remember that points are x-coordinate first and then y-coordinate. X was 0. We made x 0 to find the y-intercept, and the y-intercept is 3. So the line will cross the y-axis at the point 0, 3. The line y equals mx minus 6 passes through the point 3, 6. Let's just call that point A. It really doesn't matter. So again, to find the value of m, we're going to substitute this point into this function to determine the value of m. So x is 3, because that's the x-coordinate, and y equals 6. That's the y-coordinate. So 6 equals m times 3 minus 6. 6 equals 3m minus 6. We take the minus 6 across. So 12, 6 plus 6, 12 equals 3m. We divide both sides by 3. So m equals 4. M is the gradient of the line. So we've answered, by determining the value of m, we've answered question B as well, which is the gradient of the line. So m equals 4. The gradient of the line is 4. Okay, here we're given 3 lines. Which of these lines are parallel? And explain how you know. Okay, so we have y equals 4x minus 2. Let's call this line 1. Y equals 3x minus 4. We'll call that line 2. Y equals 4x plus 5. We'll call that line 3. Now, lines are parallel if their gradients are equal. So that's how we will know if lines are parallel. So we've answered that, we've explained that. Now determine which of these lines are parallel. Well, first of all of these lines must be written in standard form, which they are. Standard form is y equals mx plus c. These are all in standard form. So all we've got to do now is look at the gradient. The gradient of line 1 is 4. It's the coefficient of x. The gradient of line 2 is 3, coefficient of x. The gradient of line 3 is 4, coefficient of x. So of these, only these gradients are equal. They're both equal 4. So therefore, line 1 is parallel to line 3. And those are the only lines that are parallel. Question 8. Find the equation of a straight line that passes through the point 5, 3 and the origin. Okay, so we have a line, y equals mx plus c. This is the general equation of a straight line. So the line passes through the point 5, 3. So we'll call the first point A, 5, 3, and the origin, which we know is the point 0, 0. So let's just call that point B. In fact, let's call it O just to keep with convention. Passes through the origin, which is the point 0, 0. We've got 2 points here, so we can determine that we can determine the gradient obviously, but we know that the value of C is going to be 0 because that is the y-intercept, right? Where x equals 0, so this now is your y-intercept, so C equals 0. So y equals mx plus 0, y equals mx. Now we don't have to work out the gradient by using y2 minus y1 over x2 minus x1. You can if you want to, you don't have to. We've got a point here, 5, 3, which we can substitute into y equals mx now, because you know what the value of c is. So x will be 5 and y is 3. So 3 equals m times 5. 3 equals 5m. Divide both sides by 5. M equals 3 over 5. Please note that you are not to write this as 0.6. We do not work with decimals anymore. Right? We're working with fractions only. So y equals mx plus c. Y equals 3/5 x, which is the equation of the line. You can put the plus 0 if you want, but we don't do that. Right? Y equals 3/5 x is the equation of the line. Question 9. Draw a graph of the line y equals, don't like this notation. We're not using decimals anymore. Y equals a half x plus 3. Get used to not writing decimals. Cambridge love decimals. Decimals are ugly, they're messy, they're not necessary. When we do AS maths, we're going to be working with exact answers, so you need to get used to decimals, surds, pi, and all these other numbers. So just get used to not working with decimals, even though Cambridge love decimals. So we're writing this as y equals a half x plus 3. So to draw the graph, you first need to have grid paper. Okay, to draw the graph, you can either use the table method or you can use the dual intercept method. If you want to use the table method, that's fine. Pick 5 points, 5 values of x. So pick -2, -1, 0, 1, and 2 for your x values, and then substitute each of these values into the straight line to get the y value. So minus a half times -2 is -1, -1 plus 3 is 2. A half times -1 is minus a half plus 3 is 2.5. We're going to write that as 5 over 2, not 2.5 or 2.5. A half times 0 is 0 plus 3 is 3. A half times 1 is a half plus 3 is 3.5, which is 7 over 2. Again, fraction, not a decimal. A half times 2 is 1. 1 plus 3 equals 4. We then plot these points. So minus 2, 2 is there. Call that point A. Minus 1, 5 over 2, minus 1, 2.5. Minus 1, that's 3, so 2.5 is there. So the point will be here. That'll be B. 0, 3, 0, 3 is here. X equals 1, y is 3.5, 7 over 2. X equals 1, y is 3.5. So call that point D. And x equals 2, y equals 4. X equals 2, y equals 4. And that's point E. Now we draw a straight line through those points, and obviously using a ruler. We are now required to draw the reflection of this line about the y-axis. Okay, so now when we reflect functions, whatever they may be, that function shape, whatever it is equidistant from the line of symmetry or the mirror plane. So the mirror plane in this case is the y-axis. So the y-axis is the mirror plane. Now we take every single point, A, B, C, D, and E, and we determine how far away from the y-axis, the mirror plane, that those points are. So if we look at A is 2 units away from the y-axis. So when we reflect, because it's 2 units to the left of the y-axis, the reflected point is going to be 2 units to the right. So this is where the reflected point A dash, that's how we're going to indicate reflected points, just with a prime over there. Point B is 1 unit away from the y-axis to the left of the y-axis, so the reflected point is going to be 1 unit to the right. So this is where B prime or B dash will be. C is on the y-axis, so its reflected point will still be on the y-axis. In other words, another way of saying it, C is 0 units away from the y-axis, so its reflected point will also be 0 units away from the y-axis. D is 1 unit to the right of the y-axis, so its reflected point is going to be 1 unit to the left. So that's going to be D prime. E is 2 units away from the y-axis, but 2 units to the right away. So its reflected point is 2 units to the left from the y-axis. So the E prime will be over there. And now we just put a straight line through A prime, B prime, C prime, D prime, and E prime. C, find the equation of the line in part B. Okay, so now we just need the equation of this red line. So now we can do this in a couple of ways. There's the quicker way, there's the longer way. The long way is to just write down, find 2 points that lie on the red line. Okay, so we're going to call this line 2. So let's find 2 points. It's easy to find. The y-intercept is C or C prime, which is 0, 3. Okay, so we've got the point C, 0, 3. From this, automatically, we know the y-intercept. So y equals mx plus c. This value here is going to be 3. Okay, we know that because that's the y-intercept of the line. So y equals mx plus 3. We can now take any point that lies on the red line. Let's just take minus 2, 4, which is E prime. Minus 2, 4. You can take any point you choose on that line, on that red line, and substitute it into y equals mx plus 3. So x is minus 2 and y equals 4. So 4 equals m times minus 2 plus 3. Take the 3 across. 4 minus 3 is 1. M times minus 2 is minus 2m, and then divide by minus 2. So m equals minus a half. So we have the gradient of the red line, and we know that c is 3. So the equation of the red line is y equals minus a half x plus 3. Now the quick way of determining the equation of this red line, okay, first we are going to write down the equation of the blue line, y equals a half x plus 3. Now the quick way is when we reflect a function about the y-axis, all we do is change the sign of x. That is all we do. When you reflect a function about the y-axis, we change the sign of x. And conversely, when you reflect a function about the x-axis, you change the sign of y, which we're going to get to. It's part of this question. So in other words, the red line will be y equals a half times the sign of x here. This is positive x, right? So all we're going to do is change that x into a negative x. And then that's all we are doing. So y equals minus a half x plus 3. And that's the equation that we got when we reflected using the mirror plane and found points that lie on the line. This was the long way. This is the short way. You get the same equation. Y equals minus half x plus 3. Part D, we're going to draw the reflection of the line about the x-axis and then find the equation of the reflected line. So we're going to do the same exercise again, but now we're reflecting about the x-axis. Okay, so now we're reflecting the line about the x-axis. So the x-axis is the line of symmetry or the mirror plane. So the long way is to take each point on the blue line, A, B, C, D, and E, determine how far away from the x-axis each point is, and then when you reflect it, the point is on the other side of the line of symmetry, the other side of the x-axis. So A is 2 units above the x-axis, so its reflected point is going to be 2 units below. So we're just going to go 2 units below. So that's going to be A prime. B is 2.5 units above the x-axis, so we're going to go 2.5 units below the x-axis. So 2.5 will be there, and that will be B prime. C is 3 units above the x-axis, so its reflected point is going to be 3 units below the x-axis, so that's going to be C prime. E is 3.5 units above the x-axis, so its reflected point will be 3.5 units below the x-axis, so 3.5 units will be there. That's going to be D prime. E is 4 units above the x-axis, so its reflected point will be 4 units below the x-axis. So this will be where E prime is. And we put a straight line through those reflected points. Line 1 is y equals a half x plus 3. And we are required to find the equation of line 2. So again, we can just let's do it the long way, and then we'll do it the short way. Take 2 points that lie on the red line. Let's take the y-intercept because it's easy. So C prime is the point 0, minus 3, and take any other point that lies on the red line. Let's take A, which is minus 2, minus 2. So A prime rather, not A. A prime is minus 2, minus 2. So because we got the y-intercept of minus 3, we know the value of C. So y equals mx plus c. We know the value of the y-intercept, so we can just plug that in, y equals mx minus 3, and then we can substitute this point, a prime, into y equals mx minus 3. X is minus 2 and y is minus 2. So minus 2 equals m times minus 2 minus 3. Take the minus 3 across. Minus 2 plus 3 is going to be 1. 1 equals minus 2m. So m equals minus a half. So the gradient is minus a half. So the equation of the straight line, y equals mx plus c, will be y equals minus half x minus 3. That's the equation of line 2. Now we're going to find the equation of line 2, but the quick way. So when we reflect a line or a function about the x-axis, we change the sign of y. So when we change the sign of y of the original function, if we look at y over here, it's positive. So we're going to change the sign of y here, so that y becomes minus y, and everything else stays the same. So minus y equals a half x plus 3. We don't want negative y, we want positive y. So we are multiplying everything through by this negative. So minus y times minus 1 is y. A half x times minus 1 is minus a half x, and 3 times minus 1 is minus 3. And we've got exactly the same equation that we had previously.